All right. Good evening, everyone. Welcome to tonight's session. First off, thanks very much for coming out. I don't know how exactly they allocate time slots for different sessions at reInvent, but 5:30 on a Wednesday night. I appreciate that you're here and maybe just getting all psyched up for replay. And after this, you'll go out and have a good time for the evening. At any rate, welcome to the session. My name is John Winford. I'm a senior manager on the database services team. Specifically focusing on the Database Migration Service and its related products and capabilities. Don't let the slide name deter you. This is just one of those things we do to obscure things a little bit in advance of making big announcements at reInvent. So it's not necessarily accurate about exactly what we'll be talking about today. So yeah, once again, thanks for being here. Let's get kicked off and tell you what's new with DMS. So at a high level, we're going to cover what I like to call the 3 W's. I know there's more W's than that, but this is really the focus and what's relevant for today's discussion. We're going to go into a little bit of background as to what a typical migration would look for any given customer. How the phases they move through as they proceed through their migration journey, and the challenges they might encounter as they get to each one of those phases. We're going to take a bit of a step backwards, if you will, and just do a bit of a quick recap, if you will, as to how we got to where we are today. Our product launches, the problems we were looking to solve, and then, we'll get to the point of, well, what haven't we solved yet, and what are we announcing to actually solve that particular challenge that customers have. Now, I know people have seen a lot of PowerPoints in the course of this week, and you're probably due to see a few more. reInvent's not over quite yet. I always like to do a demo. Anybody that's come to one of my sessions in the past, I don't think I've ever done a single talk without a demo, and today is no different. So I'm going to definitely spend some of the time of this session getting hands-on with this product, show you guys how it works, and hopefully give you just a bit of a taste that makes you interested enough to want to go back and try it on your own environment. So without any further introduction, let's get into things. The 3 W's, like I said. So what is it we're trying to do? What is it we're trying to accomplish? There were a lot of companies in AWS's early days that were early adopters. These were born in the cloud companies, just jumped right in. They're like, hey, this EC2 thing is great. Let's start using it, right? And then we grew out from there. We had S3, and of course RDS came along. But that only worked for new customers, or at least for new offerings or new products for customers. There is still a huge on-premises legacy environment that needs to move to the cloud. We'll get to why in the next slide, but these are legacy environments that have evolved over years, if not decades. These environments, you may know what they are, and I'm certainly not looking to be critical of anybody in the audience, but it's entirely possible you may have an incomplete understanding of the data environment or the IT infrastructure. Over the years, these systems have grown. Changes may not have been properly documented. I mean, really, who likes doing documentation, right? So this is a common problem. Overall, though, this knowledge is vital to be able to determine a future state architecture properly designed in the cloud. It's often complex. You've got interdependent systems. Somebody spun up a database server somewhere at one point, and then other apps started hooking into it. And then maybe somebody took a copy of this database because they wanted to do something, unique with it, or they weren't allowed to have, full administrative privileges to it, or something like that. If you do have some sort of inventory, maybe you have a CMDB system. If they exist, maybe it's not complete, maybe it's not current. I can personally tell you a story. I used to work at a firm where we did a big CMDB exercise to the extent that one weekend, IT always has to work late, evenings, weekends, that sort of thing. We all came in and we had some external contractors, went around and we inventoried everything. Now this is a bit of a more traditional inventory. It was, your desktops and, all of the other IT infrastructure as well as the servers that were there. We attached barcodes to everything. We scanned it in with handheld scanners and what have you. Well, how long do you think we maintained that record after that big exercise? That was our bad. Not gonna deny it, but that's just the thing. These inventory systems, if they exist, are not always accurate. And if they do exist, it's entirely possible they look at it from very much a hardware perspective. Like, okay, you've got this server, you've got this desktop, great. But it doesn't say what's on that server. It doesn't say what it's used for. It's very very narrowly scoped, if you will. So from a database and analytics perspective, which is of course what we're here to talk about today, it's all a bit rough, if at all. Oh, wrong button. Always do that. Okay, so then why? Why is it that you're likely to do this driver? You guys may have seen a slide similar to this before. The drivers are all fairly consistent. Why are you going to migrate? Well, you might have some top-down mandate to do it, right? You might have a CIO saying, thou shalt migrate to the cloud. And that's perfectly viable, but there probably will be some sort of justification behind that. Your infrastructure, for example, might be nearing the end of its life. Stuff only lasts so long. You'd like to say it lasts forever, but even if it did, you probably don't want to be running that first Intel Xeon server from way back when, right? This infrastructure you have set up may not be very redundant. I've run into countless customers that are just like, yep, we've got it up and running. We basically just cross our fingers and hope that it's not going to die, right? So you might want to investigate leveraging some of the features that are available in things like a managed database where you get things along the lines of multi-availability zone, right? So built-in redundancy. I know there's probably some DBAs in the crowd here. Setting up your own redundancy with things like log shipping can be quite laborious to do. So AWS manages all that infrastructure for you, from power and low-level hardware through to networking, storage, and CPU to ensure that all your applications and databases are available when you need them. Scalability, another big reason why people would move to the cloud. With AWS, you can scale your instances up and down as required, right? It covers both CPU and storage, but also offers specialized instance types for unique workloads. An example I like to give is, say you need a lot of graphical power to do some sort of analysis on images. Well, you're going to choose a different type of instance to do that than you would for a database. With DMS, which of course we'll get into a little while today, we have a fairly narrow scope of instances available. We started off with T2s, moved to T3s. We've got C-class machines, Rs and Ms, and that's really because, frankly, it gets used as a processor. And maybe you need to adjust the dial a little bit on memory, but there's no real reason to offer the full gamut of instance class machines that, say, EC2 does. But when you're looking to move to the cloud, obviously we're not talking about just the database, so it's great to have those options for other type of workloads. When you go to the database space, of course, you don't have to just use the prepackaged database that's available either in the open source community or from some licensed software vendor. You can leverage things like Aurora Read replicas. So if you need to scale out in a way that was very hard to do in an on-premises environment, with an Aurora Read replica, you can have up to 15 replicas up and running to really scale those reads. So you can do things like leverage the power that is really hard to do in an on-prem environment. And then, of course, it's engineered for the cloud. If I take that Aurora example again, the Aurora Global Database is designed for globally distributed applications. It allows you that one instance to be able to not only have multiple redundant copies in one region, but you can actually go cross-region as well. So if you had your main workload here in, say, Virginia or Portland, you could have another copy of it over in Frankfurt if you wanted to. All done with very high performance and low redundancy. And then, of course, the other good thing with the cloud, being pretty straightforward, is cost, right? You only pay for what you need. You scale up, you scale it down. You only pay, sometimes it's done on per second, sometimes it's, per hour billing basis. But it allows you to scale up and scale down as your demands change. The prime example I always like to use is one that's very close to home for us at Amazon, the Amazon.Prime Day, right? So before Amazon moved to AWS, and again, that's a bit of a backstory if people didn't know that originally when AWS was launched, Amazon still managed their own hardware and infrastructure. They only recently moved to AWS. They used to have to deploy and provision for the peak days, which in our case was Prime Day. So we used to have to buy the biggest, baddest databases for Prime Day, pay for all of that compute power, and only use it for one day. The other 364 days of the year, we were just paying licenses for the heck of it. Not to mention the fact that we actually had to buy all the compute to go with it and power that as well. So, that's some of the power that you get when you move to managed services. Also giving you choice, right? Choose the right database for the workload. You don't need to be locked in because that's the software you purchased. That's the only option you have. If it makes sense to have something in a key value pair database and another bit of it in a relational system, you can do that. You get access to the latest and greatest new hardware. kind of lose count at how many new instance types we launch at a given reInvent, but we saw some new Graviton instances launched, I think it was yesterday. You get to get hands-on with that right away without waiting for your next hardware refresh cycle to come along to buy that latest hardware from your vendor. So all of it sounds great, but like I said, do you really know what you've got? If you need to make that move, what needs to be migrated? What's going to be the best choice for target systems? The load that's on those systems, the applications using it. Assuming you even have all of this information, then you need to somehow amalgamate it and make a good decision as to where to go. So these are all some of the challenges that exist when you're moving to the cloud. So just a few seconds more on why one would migrate. I always like to say, look, it's best to talk to impartial people. We work a lot with analysts who, talk to us and other cloud vendors and, do some detailed examination of customers and really look at the benefits that these people have seen in real life for making that cloud migration. So this is a study from IDC looking specifically at the impact of RDS. So, not looking at Aurora or anything like that, but just the core RDS being your Oracle, SQL Server, MySQL, MariaDB, and Postgres. And they found that looking at multiple customers in multiple industries, from small to large enterprises, they looked at both the quantitative and qualitative data and came up with some measurable benefits. You can see them all up on the screen. In essence, though, they took a composite organization by looking at all of those different enterprises, taking all the results, and came up with these figures. So, your mileage may vary, right? Because, everybody is not quote-unquote average. But there's some pretty significant savings that IDC found by moving to the cloud. And a good chunk of the reason why that is, and I do tend to use this line some, so if you've heard it before, it happens. Managing a database or an analytics system is not special, right? Lots of people can do it. The fact that you can do it doesn't make you any different from your competitor. So by allowing a cloud provider to manage your service, like something like on RDS, you can spend more time building your product and differentiating your business than you would if you were just spending that time making sure that your backups worked last night. Right? So this is where some of these savings come from. We experienced very much the same thing at Amazon. When Amazon.com moved off of all the self-managed systems to AWS, a good chunk of our staff that were maintaining our database and infrastructure environments became database engineers or maybe transitioned to software development engineers and now spend more time making the core Amazon product better rather than making sure that database is up and running. So say you're going to do a migration. I don't know if you guys have experienced this, but I've certainly dealt with, I don't want to say necessarily my managers, but I've worked with enterprises in the past, and they have a bit of a, definitely when you get to the more senior levels of management in particular, they have a bit of a, let's just call it vague view of what IT can and cannot do. They just go, oh, this is technology. You must be able to do it, right? The fact is, planning a migration is not necessarily for everyone, especially if your database is just something that's kind of there on the side. You need to really understand what it is you've got. You need to understand that existing estate. You need to recognize the applications and the database and analytics systems that you have. You need to know which systems are in support and out of support. I mean, if somebody's, say, got MySQL 5.6, that's not technically in support anymore, and maybe you're not aware of it. Same with some older versions of Oracle or SQL Server. So, there does end up being some contextual relevant IT knowledge that you have to have when doing a migration. Also helps if you can recognize which systems are dev, test, prod infrastructures. Maybe if there's some duplicates in there, you don't want to spend the time and effort moving the duplicates. You just want to focus on the few particular systems that you need to move. And then it's also very relevant to know how to map that legacy infrastructure to modern cloud systems. So, that 10-year-old server that you have, do you know what's the most appropriate system to map that to when you go to the cloud? CPU power, Moore's Law, still growing exponentially here. So just because, it was the biggest, baddest server when you bought it, doesn't mean when you migrate it, you need to go to the biggest, baddest server in AWS. And then, of course, you need to appreciate what the options are when migrating to open source or cloud native systems. I've been with Amazon now for more than 7 years. I've seen the number of services we have grow exponentially. I can't keep track of them all. I'm pretty sure everybody in this room can't do that either. So it's really good to have something that will provide you some guidance and go, actually, this system looks pretty basic. You may be running on a commercial system right now. Maybe you want to consider looking at open source as part of that migration. All right, so let's talk about the phases of a migration as things are going along. Assessing your application portfolio and determining the application migration pattern for each of the applications is critical to the success of your migration. On screens, it's just an overview of potential migration steps. I say potential as not every migration does all of the steps. Only if you choose to say refactor, do you have to do steps like schema and application code migration. And actually, I should take a step back and say this is phases of a database or an analytics migration, right? This isn't necessarily the phases you'd go through if you were doing, I don't know, a storage migration, for example. We've talked to a lot of people in our time at AWS being involved in migrations, and early cloud adopters from CIOs and large enterprises have warned us that you don't necessarily want to jump straight into an all-in refactoring approach. That sounds really good on paper, like, yeah, let's get off of all the old guard onto open source right now. But the problem is if you do that, it can result in a lengthy design process before you move your first workloads. Based on their advice and witnessing customers have success, you want to really look at your workloads and go, actually, these ones will probably be good candidates for lift and shift. These ones, yeah, let's look at these ones for refactoring, and maybe we'll do that. And the ones that we lifted and shifted to the cloud, maybe you want to look at refactoring them at some later point in time. Quite often, we've encountered customers that have pretty hard deadlines in their migrations. They have a data center exit coming up. They don't want to renew the lease, or maybe their hardware is getting to end of life. I was just speaking to a customer today that they regularly, and I think when I say regularly, I mean every month, experience at least 5 hardware failures. So they have some good incentive to migrate in short order. Overall, though, before you get going on a migration, you have to understand what you have. The view on screen is really just a zoomed-in migration of a specific workload. So let's think a little bit bigger. Now we're getting there. We need to think about how you would migrate an entire data center. Maybe how you migrate a particular fleet or an estate. You need to understand what you have, understand the complexity, and the potential migration targets. It can take a long time to build that inventory, to scan that environment and build a plan. Maybe you have that CMDB I was talking about earlier, but quite likely doesn't have that database and analytics specific information I was mentioning. You need this information to support the creation of a TCO, or total cost of ownership model, to help build business support for your migration project. Now, maybe you might be able to get away with that without that if you've had some senior C-level executives say, thou shall migrate. Maybe you don't need to justify it. But I can say that in general, I've found that you have to justify putting all of the time and effort into a migration before you get going. So therefore, you need that more detailed level of analysis to say, hey, look, this is what we've got, and this is what it's going to take to migrate. The second phase of the migration is where you learn and plan things out. You need to build your capabilities and your experience. Now, if you're going to engage, say, professional services or an AWS partner, you can maybe skip this step, right? They'll do this for you, and they'll hold your hand through the way. But in general, you need to understand the migration tools that you're going to use. You need to understand the potential migration targets, skill up on them, get comfortable, and then start iterating, right? And it's during this migration and modernization phase where you'll continue to migrate waves of applications and operate and optimize your cloud environments. As I said on the previous slide, you're not necessarily going to do a big bang all at once. You'll understand what you have and plan it out and get that migration going. All right, so a little bit of a history lesson, if you will. Who was here at reInvent 2015? Anybody? Don't see any hands, so you probably don't recognize this slide or this picture. Anyways, this is Andy Jassy, back when he was head of AWS, launching the AWS Database Migration Service. We launched it that year. We kicked off with the beta program before going GA in March the following year. At that time, we only had a limited number of sources and targets, not to mention far less in the way of features and capabilities that we have today, like data validation, transformations, and so on. Even so, it was the first step on a journey to make it easy for customers to move their data between database engines or analytics systems, enabling database freedom, if you will. One of the things that's quite unique about DMS, if you haven't picked up on it, is it's actually more than just a database migration service. The name's a little misleading. It can replicate data. It's one of its big powers is you can replicate data from A to B, and you can go between different database engines. So you can go from Oracle to Postgres, or from MySQL back to SQL Server if you wanted to. It's entirely possible. And because it's a logical replication product, you can do only a subset of the data if you want. So lots of people actually use DMS not to migrate the data, but to actually extract information out of particular workloads and do things like feed a data warehouse or a data lake. But overall, it's all about enabling data movement into the cloud, out of the cloud, between systems in the cloud. You name it, DMS is a pretty, like a Swiss Army knife for data migration, if you will. Makes it easy to move data between your sources and targets, wherever they may be. At the same time as launching DMS, we also launched the AWS Schema Conversion tool. Now, this is a bit of a unique product from an AWS perspective. It's currently available as a downloadable tool from our website. And what it does is it actually converts your database schemas. If you think about a migration in a database, you've got two components of it. You've got the schema defining the structure of the database. What are the tables you have? What are the stored procedures, triggers, constraints, and all that sort of stuff. And then you've got the data that resides in that database. If you were to just go, and I don't know how many people have used DMS here, but if you were just to go start up a task with DMS and start migrating data, DMS will happily do it. It'll go and create the tables that it needs on the target system to populate with the data that you're looking to migrate. But it only populates what it needs minimally. So that means your table names, your columns, the data types, and a primary key. Nothing else. You don't get constraints, you don't get triggers, and you certainly don't get things like stored procedures. That's where SCT comes in. You use it first to convert your database schema from one database to another, and then you use DMS to move it. Same thing goes for data warehouses. It'll convert your data warehouse. So say you had an Netezza data warehouse and you wanted to convert it to Redshift, you can use SCT to do that. But in the data warehouse space, it's a little bit different because you actually use SCT to move the data as well, not DMS. So just if you're taking a look at it, just know there's a little bit of a difference there. And the reason being data warehouses are generally fairly static in that they'll get updated, in a batch process once a day or maybe a couple times a day. So with SCT, it's easier just to dump the data because it's already a local client and then get it shipped up to S3 for ingestion into Redshift. Other things that it can do, it'll support the conversion of, say, an Apache Cassandra system to Dynamo. It'll do ETL modernization. And people may have noticed that we recently went GA with Babelfish. Now, if anybody is not aware what Babelfish is essentially a feature of Aurora Postgres that on a different port allows you to fire off T-SQL commands, also known as SQL Server commands, at that port, and Babelfish will interpret that and operate exactly as a SQL Server database engine. So it allows you to do rapid migrations because you don't have to worry about doing the conversions if you use the Babelfish port. It's not 100% compatible with SQL Server, although we're very close, and SCT actually has a capability in there as well to do an assessment, if you will, to determine the compatibility between an existing SQL Server system and using Aurora Postgres with Babelfish enabled. The one other thing SCT does, I always like to make sure I point this out because it's not always immediately obvious, is it can do application modernization as well. So you can go in there and have it scan your source code of, say, a Java application, and it'll locate the SQL statements in there and update them from, say they were Oracle statements written in PLSQL, it'll update them to, for argument's sake, Postgres statements running PGPLSQL. So it does that app code conversion layer as well. Wrong button again. There we go. All right, something's missing though. So we can convert, right? We can convert with SCT. We can migrate with DMS. But if we think back to that migration phases that I was talking about earlier, what about this whole discovery thing? So that's where AWS DMS Fleet Advisor comes in. Now you guys probably saw this on the keynote earlier today with Swami. We're going to drill into a little bit more detail than he did today, and this is the missing piece of the puzzle. We now have an open preview of AWS DMS Fleet Advisor available for you to use today. As a bit of a backstory, 5 years ago, this probably would have been launched as a distinct service, but with all of the services and the complexity that, not so much the complexity, the knowing which service to use when, it made sense to integrate it into DMS because, as I said, if you're going through and you're doing your phases of your migration from discovery and analysis through to conversion through to migration, it makes sense to put it all in one place, and that's why we've launched this as a component of DMS. So what does it do? AWS DMS Fleet Advisor is a new capability of the Database Migration Service that automates planning for AWS customers who want to migrate their database and analytics workloads to the cloud. To help customers move faster, it automatically builds an inventory of on-premises database and analytics systems, analyzes them, and provides advice using customized migration plans. So it goes in there, has a look at what you got, does an analysis and says, this is all of the information I can find. Here's some things you should suggest doing with it. Looks at those databases and highlights problems, duplicates, areas of concern. But we'll get into a demo pretty quick, and I'll show you guys exactly how that works. I want to highlight that it is an open preview, so it's only available in the Virginia region today. We'll be making it available in more regions shortly, and of course also expanding the functionality because there is always this deadline you're running to for reInvent. We have many great plans for the service. So first version we really wanted, and we're excited to get it in people's hands. So we made sure we could get it out in time, but that's why we just got it in one region to start with, but you'll see more in the not too distant future. Fleet Advisor is fully integrated into something we call DMS Studio. DMS Studio is really version 2.0 of the DMS console, if you will, where we're trying to hook in all of those components that I was talking about of the migration journey into one place. So from that discovery through to migration, discovery, conversion through to migration, all hooked into DMS Studio. The idea is it accelerates customers' migrations for both database and analytics migrations by providing a seamless experience through all of those phases. Each point in the path, Studio identifies the relevant use case, adjusts the migration workflow, and suggests next steps. So for example, Studio might detect a change in the database engine, such as from Oracle to Postgres, and then guide the customer through and say, hey, you should have a look at the Schema Conversion tool. Maybe then gives you more information about application code conversion, and then on to next, the database migration. The idea is it's going to give you contextual documentation, examples, and options to engage experts for assistance at each phase along the journey. It's going to build out with intelligence as time moves on, but overall, it's about giving you that information going, okay, look, you look like you're doing a conversion. Have you considered reading this blog post or maybe engaging experts at one of our partners to find out more? So it's really just trying to guide you through that migration because we totally appreciate that not everybody is a migration expert on day one. And finally, DMS Studio has centralized dashboards, and the idea is we're going to give you a single pane of glass view into all the migrations that you have going on, making it easy to get progress updates, identify and troubleshoot issues, and reduce overall time and effort on migration projects. I want to also highlight if anybody is using, say, the AWS Migration Hub, DMS is fully integrated into Migration Hub, so you'll get that information flowing back there. And if you haven't looked at Migration Hub before, it has more of a statewide view of things, looking at everything from app servers through to storage, as opposed to just database-specific information. So just depending on the type of project that you're looking at doing, you have different levels of products and details that are available for you to use. So DMS Fleet Advisor, what it does is it discovers the right path for database and analytics optimization. What it does is it uses an agentless central engine to collect varying kinds of data, both structured and unstructured, on nearly any infrastructure. With the database and server hardware profile, operating system information, and metadata in hand, DMS Fleet Advisor can determine the risk to your business based on product supportability and new feature adoption. Our first consideration is to look for databases and servers that are running on versions of either the operating system or the database itself that are out of support or on extended support. These servers represent a business risk that you need to address. And we also look for software that's running just on aging physical servers. So again, I want to highlight that this is generally targeted towards an on-premises inventory. We have a single install that goes out and gathers all this information and pulls it back. You don't need to install agents on every server or anything like that. And if you did want to do it, it's also possible to run it on an environment that exists in the cloud. So if you had a VPC, you wanted to run it across and see what databases were living on all of those possibly hundreds of EC2 servers you have, that would work perfectly fine as well. But generally speaking, we see most people using this in an on-premises environment. So what does it do? The collector finds a range of objects on your network to monitor. Of these, you select which from the local collector you want to monitor, and when it starts, we collect information about the databases, schemas, and objects we find on those servers. It connects those servers, PCs, and databases to connect key performance metrics in real time. It includes IOPS, memory, processor, disk usage, metrics like that. Fleet Advisor also discovers existing licenses with the aim to reduce the number of licenses, thus lowering your maintenance costs. So, you know, again, remembering that this is an open preview, we're collecting a bit of information right now. We're using a lot of it, which you'll see in my demo today, but there's some more good information to come, or good features to come in the not too distant future. One of the cool things about the collector, though, if you know there's some security concerns and you're wondering, well, what is AWS doing with all of this? You can review the data that we collect on premises first before it gets uploaded back to the cloud. So, you know, there's no secrets going on here. You can definitely have a look at what it's doing and you filter it out if need be. And you'll see this when we get to the demo, but you can specify, no, I don't want you to look at all of these servers, just check out these 10, for example. So, you know, very much giving you the control as to what you want to look at and what you don't. And then we just will interpret that data and present it to you in a way that you can use it to get going on your migration. As I said, in the end, we present the results on the AWS console. I'll show you the complexity based on the lines of code and objects and the count of objects. We'll look at the similarity between multiple schemas. So say, for example, you might have a staging and a prod environment. You'll get duplicate schemas. When the analysis runs, we'll go, hey, these look the same. Maybe if you're going to do a migration, you only want to move one of them. This screenshot doesn't show all the columns of data. I'll show a couple more when we get into the demo. I think I was mentioning earlier, technology has advanced over the years with faster CPUs, greater memory capacity, and new storage technology, things like solid-state drives. These servers, you know, servers that are running on old technology are great candidates for consolidation or virtualization. The analysis also looks at the database usage to determine if a candidate is possible for, you know, decommissioning or scaling down due to its lack of use. So once again, I want to reiterate its preview. We'll be adding a lot more capability in there, but as it is, it's still pretty cool with the information that it collects. And as you can see from, actually the screenshot doesn't show it. Oh, it does. We're already gathering more information than your typical inventory and analysis tool does, because you can only see all of the schemas that are on your database and database server, you know, as opposed to just going, oh, hey, it looks like there's a database engine running here. All right, I told you I'd do a demo. Now I'm going to jump into it and see how it works. Just make sure my computer hasn't gone to sleep, which of course it has. So just give me a second. All right. And there we go. The guys have already done it for me. Thank you. All right, so here is DMS console. Full disclaimer, the URL is not the URL you're going to be using. Because we literally just launched this morning, when I had to present and create my whole demo, I had to do it on a pre-production environment. So this is what you're seeing here. Yeah, it's going to look a little bit different than a real prod environment, but overall it'll give you a pretty good idea. So you log on to your AWS console, you navigate to DMS the same way you normally would, and as I was mentioning, this is all part of what we call the new Studio experience. So you can go here on the left-hand navigation pane, as soon as I can find my mouse. There it is, and you enable the toggle here to turn on the preview. Okay, so once I've done that, you can see I've got a few more menu options here for Fleet Advisor. Again, I want to reiterate, this is only available in Virginia or IAD, so if you go to another region, you will not see it there. But you can go in there and you'll see there's really two components, data collectors and inventory. So I'll start off with the data collector just so you can see what it is and where it is. Right now we have just a single collector created. Now I pre-created this last week because I had to actually run this in advance so I could show you guys the results. Because this is essentially doing an inventory of a collection of servers generally on premises. It's not something I can just run on the spot, right? You want to let that run for a bit of time. So, if we wanted to do a demo of this live, you guys would have to stay for a lot longer session. And again, as I said, I'm happy you're here tonight before the big party anyways. So it's been pre-created. You can see I did it last week on the 25th. For the preview, we have limited the number of collectors to 3. So why would you ever want more than one collector? I'll get into it in a second when showing you how the collector works, but in essence, it scans your network and looks for servers. If your network is segmented, maybe you have different regions that you operate in, or maybe you have a prod network, and then you have an entirely different one for your development environments or what have you. You would need to install a separate collector on each environment in order to gather the data from all of them. So that's why you would have multiple. You can see here that there's a Create Data Collector button. I'm not going to do that now, but what that does is it actually creates a unique collector for you. It basically generates an install file with some configuration data so that when you install it on your local network, it knows where to connect back to. You don't want his collector responding back to your database instance, right? Or your AWS instance, I should say. So essentially what you're doing is you're generating a collector with some configuration components so it knows which AWS account, which region to connect back to. So that's why it takes a couple seconds to create it. And what it does then is that collector actually gets generated and copied into your S3 bucket that we create on your behalf. And then when the download starts, when the collector's been generated and available to download, it comes down from your S3 bucket. So that's what's happening there with the collector. I'll show you the results in a few minutes, but as I said, because this is an on-premises type tool that takes a little while to run, I had to pre-record a video of it happening. I'm not normally one for doing video recordings. I prefer to do it live, but it just wasn't feasible this one. So I'm going to flip across to the video. Just a second. All right, let's see if I can talk as fast as it goes. Maybe I'll stop it in time. All right, so as I said, the first step with the collector, once you've generated it, is you have to install it in the on-premises environment. I told you about the metrics that it collects, so all this information is being recorded, and then we do some analysis on it to help you understand your inventory. All right, let's move on. All right, so the first step is the install. So actually, disclaimer number 1, I think a number of you have probably seen this, this kind of screen before. At this point in this preview, the collector needs to be installed on a Windows-based machine. Right? So if you have a server environment or environment that's entirely Linux, hopefully you have at least one box sitting around somewhere, because at the moment for this preview, collector is a Windows install. So go along and we install it, accept the terms, say where you're going to install it, away she goes. And then when it's done, what we're going to have are the credentials configurator appear. What this is doing is the collector installs essentially as a service, goes out and does its thing, and you can view the results in a web console afterwards. So these credentials here are the credentials that you're going to use to log on to that web console. Again, the information that's being collected, you don't necessarily want available to everybody, so that's why this username and password on there, so that if anybody stumbled across the web server, so to speak, they wouldn't be able to log in and see all of the information that the collector has gathered. So put in a username and some passwords. Make sure you put in something at least reasonably strong. And then she's up and running. So what we have here, this is the web server. You can see there's a few different components to it. Right now, obviously, nothing is running, and you've got where we're forwarding the information back to, right? And all of the drivers. So again, this is a more detailed level analysis than a lot of existing discovery tools are. So if you have a particular database server on your network, we need to have those drivers for that database. Now, we've already pre-installed them, in this case, on this machine. The collector does a check during the install to make sure the drivers are there, and if they're not there, it will prompt you to install them. Again, I always have to apologize a bit for this. The same thing exists with SCT. We cannot bundle the database drivers with the install of the collector. The lawyers from the respective database vendors say no, so you actually have to go and have the JDBC file, go download it, from the various sources, put it on the box, and then, the collector will happily use it. But unfortunately, we can't bundle it in, so that's one of the first things the collector does is validate that you've got all of that in place. All right, so it's installed, it's running. Wait a second here. Now we're going to configure it. So as I said, first step, configure, get it up and running. We're going to configure the credentials. Now these are the credentials to access back to your AWS account. So the collector gathers all the information on premises and eventually uploads it back to AWS. So that's what that's all about. And then go and make sure that all of the drivers are there. If you don't have those IAM credentials configured, obviously we're not going to upload the data back, so you can check it out in advance before that happens. Now we're going to go and add a server. Now what this is, to do the discovery, we're connecting to LDAP. Right? So you're basically going to enter the information for your domain controller, a username and password that has access to query that information, and then you can see it's been added down there in the table on the in the bottom, and it checks that the credentials are valid before we continue. Once that's done, it's time to move to the actual discovery part of things. So let's get going and do the first level of discovery. So it's going to hit Run Discovery, confirm the domain controller that you want to do or want to use, because of course you could have multiple configured, and then it goes and finds all of these servers on your network. And you can see it finds their name and some information about them, what type of operating system we're running. You can filter down. In this case, we're looking just for, say, Microsoft SQL Server systems, and we're saying we want to monitor those few systems, as well as I think that was a bunch of Oracle ones we just grabbed. I'll just pause this for a second. So again, out of all of the servers that it discovered, we then filtered down and said, okay, we want to look at just these Oracle hosts and just these SQL Server hosts, okay? So it's going to go through and validate that it can make a connection to them. So that's what's happening right now. And you can see there's an error here. We can't connect with the current credentials that we have for the domain controller to this particular Oracle server. So we can go in and we can edit these credentials to something that does have access to the server. So that's what we're going to do here. And actually, we're going to edit all 4 at once, because in this case, let's use the same credentials for all 4 servers. Put that in, update, confirm the overwrite, and now do the scan again, and everything's passed. So now we have established a successful connection to all of those database servers you saw on the screen. Now that it's ready to go, we're going to go and take a little bit further depth. So at this point, actually I should clarify what's happening here. We can say we've found a bunch of servers. Now, of those servers that we've found, which ones do we want to do a deeper analysis specifically about the databases or analytics systems that are on them? So it's sort of filtering down the list, if you will, so you're not scanning your whole network all the time. And when you're filtering down the list, what's happening here is it's saying, do you want to look at just the servers that you've already narrowed down, and that's what this monitored objects filter is, or do you want to go back and look at LDAP again and get the full list? It's kind of giving you the option. You could jump straight into this database component without having done that first level server discovery, but it's just letting you go step by step. First, grab all the servers, and then say, of those servers, which do I want to look at for more detail? So that's what we're doing right here. So select all in this case. We want to monitor all of those servers from a database perspective. So now we've got those here. And yeah, I'm going to add them to the monitored objects. And as we move to the monitored objects, you can see everything that we're looking at. Right? So we've got quite the range. As you saw way back in the first step, we said we wanted to look at the operating system, and now we're filtering down, just doing the database stuff. Changing the credentials again for these particular boxes. There's some failures in there, so we can fix them. There's a bit of an iterative process to get all of the creds working properly. And we're good to go here. So you can see we're looking at Oracle boxes, SQL Server systems, Linux and Windows. And actually, what we're doing here, let's pause this again, is if for whatever reason a server isn't discovered through LDAP, you are able to add it manually. So you can just enter in the information, its IP address, the username and password to use, and it'll go, okay, I'm happy. I'll go monitor that one. I didn't find it, I didn't see that it was there, but you told me it was there, so I'm good to go. So I want to highlight that part of what you could do here is you could actually just give it a full list. You don't have to let it discover. If you know these are all your database servers that you want to do a deeper level analysis on, you could just do an import. Actually, you don't have to add it one by one. That's what you'll see next, is you can do an import with CSV of all of your servers, and we'll happily take that information as well. So that's what this is showing here. There's a sample CSV file you can download. We've got one already pre-created, and as we do that, you'll see we've got a couple more servers that have been added to the top that we're going to monitor and do some analysis on. So that's what's happening here. We'll look at all of these servers, and once things are good to go, we're going to start collecting data. And this is something you can let run as long or as little time as you want, but eventually, in this case, it runs pretty quickly because we've compressed the time for the sake of the demo. We're going to monitor all this information. We're running quite a range of queries against the system. So you can see we're getting some processor information, some CPU stats, getting some SQL object information. So we're collecting things like the number of schemas in your database, the number of objects in each schema, the number of lines of code in there. Again, all to help you make an educated decision as to what are good potential targets or how easy or hard it might be to do some refactoring. So that's what all of these different things that we're calling queries are, just gathering different levels of information. Go through, and then eventually what you can see, and this happened pretty quickly because, as I said, they turned it down. I'll just go back 10 seconds, and I'll stop it at the right time. All right, you can see that in this case, the data was uploaded now to AWS, right? So as I said, I did this last week. Data got uploaded. And that means it's now available in the DMS console for you to do some analysis on. All right, so that's it for the video. Let's switch back to the actual results. So I've gone back to the DMS console here. The information's been uploaded. Oh, sorry, can you flip back to the video? My bad, or to my laptop? Perfect, thank you. So we've got the information here. You can see the data was received. I admit the dates are a little bit off from the video, but that's okay. It's the same data set. And now we can look at what it is that it's actually done. So let's have a look at the inventory. All right, so again, for time purposes, I've already pre-processed this data. Normally, if this was you and you'd get this information, the first step you would do is you would actually just see the databases and the servers that were there. You would run this analysis. And what this analysis does is it goes and it looks in greater detail at the information that you provided to us. And it looks at each schema and goes, oh, like I've seen this schema before, it looks pretty similar, or oh, this version of the database is out of date. So your first step after you've uploaded that data is to run this analysis. Generally runs pretty quickly. We have had some very large estates, under our testing that can take a while to run, 15 minutes or so. But generally speaking, it's the analysis that gets you the useful information. So as we're in here, you can see we've got quite a range of database servers. I'll find my mouse again. And they've got, in this case, we've got your IP addresses and what have you, the number of schemas on each one of these databases, the engine type, and of course, I was highlighting before, things like whether you're running an old version, and then what do you do with that version? And right here, you can see in this case, you can click on it and says, in this case, you're in extended support until October 21st, 2023. I don't know about you, but I didn't know that. So it's good to have this information presented to you in a pretty clear and concise way. Obviously, this PostgreSQL instance is good and happy. We're in mainstream support that runs until November 10th this coming year. So basically, reInvent next year, this one might be a little bit problematic. Tells you about the engine there. You can also go and add some extra columns. They're not all on by default, so actually this is not the one I wanted to show you. Just give me a sec. And we can go and click on, say, let's look at this one. If we click on a particular database, go in here, you can now see everything about that. So this is this particular database, its IP, service pack and OS and what have you. And then you can see here are all 15 schemas that are on that particular database server and the complexity in our view of each of these schemas. Now, what does complexity mean? It's a bit of an algorithm I haven't had the developers explain to me quite yet, but it's looking at the number of objects and the number of code lines in each of those objects and basically saying this is how easy or hard we think it's going to be to migrate. So I need to actually check to see if it's something we've documented. If not, we'll get that up there before too long. But in essence, we're taking a bit of a high-level guess and going, this looks pretty straightforward versus it looks harder. What you can see is there's also this similarity thing here. So what this is saying in this case, this particular schema, which again, you can tell we're using a demo environment here because the schema is called test, right? But it's 100% similar to another schema, right? So if you're going to do a migration, you don't need to migrate it twice. You probably only need to migrate it once. And then in some cases, well, it's actually very similar, but not quite the same. So this could be something that you maybe need to dive into in greater detail and find out, well, why are they not the same? Do we really only need to move one versus do we need to move both of them? You don't have to do it all at this level. Actually, I'll just go into here. This is what I was meaning to show you. So you can turn on some other toggles, if you will. So how many lines of code there is, for example, how many functions you have, how many packages you have. Let's go and say turn on tables. That could be good. Confirm, and now we start getting this extra information up here on the console. So we've got, lines of code and tables, right? So, again, giving you information that's definitely accessible to you before, but just harder to find than putting it all in one place. If I go back here to the inventory, you can also do, instead of looking at it on a database per database level, you can go and look at it on a schema level. So we can see now we've got 454 schemas. In this case, I can tell you by looking at it on a schema by schema level that Fleet Advisor has said, okay, this MSDB, this is probably the primary one, if you will, and you can see that this one right below it, 100% similar to the MSDB above it, right? So you don't need to look at a database. You can go schema by schema and see all the same information there. So this is all the sort of stuff that Fleet Advisor will collect for you. And I also want to highlight that you can export it, right? You can use this for other purposes. Say you wanted to send this information to a partner to get their opinion on it, or maybe you were working with somebody at AWS and you wanted to say, hey, look, this is what I've got. You can export this to a CSV file. Open that up. And we've got all the information there, readily, easily available for you to use. Yeah? So when it says 50% similarity, that means it's found another schema in the inventory that has 50% of the objects and procedures and what have you the same somewhere else. That's what it means. So when we look at this data file, it's pretty straightforward. All very similar information to what you saw on the screen, but one thing I do like is it's got this unique identifier that it's just attached to each schema. You can see it's just purely numerical, so that when you look at it, you can see this is schema 1. I think this should be this MSDB one we were just looking at. Maybe it is, maybe it isn't. Oh yeah, it is. There it is, msdb.dbo. We've labeled it schema 1. And then when you look at this next one down, this is the one where we said there's 100% similarity, and you can see we're referring back to the schema number 1. So it gives you quite easy to track things down, see where those duplicates are, and have some more educated information to decide on your next steps for your migration. Yeah. It looks at the code. It doesn't look at the data. So it'll look at the code in your procedures and what have you, but it doesn't look at the data and say, oh, look, you've got exactly the same data between the two databases. When we're at a high level, if I go back to that overall migration flow that I was talking about, we look at this as a sort of a next level down of analysis, if you will. Like, it's not just high level going, oh, look, you've got a server. It's like, okay, we'll tell you about some of the stuff that's on the server. If you were ever considering doing a heterogeneous migration of this, so say you had an Oracle database and you wanted to move it to Postgres, before you would embark on that, once you've narrowed it down and gone, I want to do these 5 databases with Fleet Advisor, you would then go and use the Schema Conversion tool afterwards to do a more in-depth analysis. It goes much deeper and really says, oh, look, I can truly convert this stored procedure from PLSQL to PGPLSQL, if you will. So this is like, your high-level pass across your whole fleet, giving you a good idea of where to focus, where to go next. And then when you want to do that deeper level analysis on a subset of your databases, that's when you would pull out SCT to do that. No, the collector component is a thick client that you install on premises. At the moment, yeah. Yeah. As I said, preview. Well, I think you guys can all see we've probably got some neat things we can build into here, but we wanted to get it in your hands as soon as we could. So yeah, pulled that one out. And with that, I think let's switch back to the PowerPoint if we could. All right. A few last things. We're getting towards the end. The details. There's always some details in there, isn't there? Preview. So what does preview mean? Preview means we are currently only discovering MySQL, Oracle, SQL Server, and PostgreSQL databases. There's more to come. We want to get deeply into that analytics space. We know there's a lot more databases out there than just those four. Just as a, I can't talk about roadmaps in the public environment, but I think you can see if you look at DMS and SCT and all of the different sources and targets it supports, gives you an idea of where we're probably heading. So we'll be building that one out as time permits. What sort of information do we collect? As I mentioned before, the schema information we collect is not at the same level of depth as with SCT. We use LDAP to get that high-level inventory. We then use WMI queries for Windows to pull the information out, SSH queries for Linux. I mentioned earlier some of the information we collect, as I said, the RAM, the hard drive, network information, looking at the versions that you're running, the patches you might have on there. We're very much looking at the number of objects and the code in those objects to see, again, that it's similar or not so similar to something else, and the RAM usage of that server, so that eventually we will be able to tell you what an appropriate size instance to migrate to will be. So in the end, overall, we're trying to analyze the data to help you develop a roadmap for your cloud journey. We're going to look at your infrastructure, see where the optimization opportunities are. We're hoping to be able to give you an idea as to possible options to run workloads on AWS. One of the things, as I said, that people always want is a financial model. This way, it's very easy to get that dump of data and go, hey, here's all my databases. Therefore, we at least know that there's 293 of them, and therefore we have a bit of an idea what it might cost if we move those to AWS, even if we just use sort of a generic cost value for each of those. Overall, we're trying to help you make informed choices according to business needs and goals. There's a lot more we want to do with Fleet Advisor, but as I said, we wanted to get it in your hands as soon as we could. So hopefully that's been of interest to you. One of the questions that might be coming up in your mind though is, well, hold on, doesn't AWS have other things that are kind of like this? We do, and there's some overlap, but these products are generally very complementary to each other. Fleet Advisor is intended for users looking to migrate a large number of databases and analytics servers to AWS. When you're ready to migrate your database and analytics fleet, you should use it. It'll do your analysis at a level deeper than some of these other products. The idea is we're hoping to build a customized migration plan by looking at the complexity of these. The AWS Application Discovery Service and Migration Evaluator Collector are targeted for broad-based compute and attached block storage discovery. The Migration Evaluator Collector is used by customers that are starting their migration journey who are looking for a data-driven business case to move to AWS. AWS is used to feed the AWS Migration Hub, to visualize server-to-server dependencies, created application groups, and to track migration progress. The Migration Evaluator and ADS are ideally used to help you gain early insights of your inventory portfolio, and subsequently, when you're ready to perform a deeper level analysis of your databases and analytics workloads, that's when you're going to use DMS Fleet Advisor to create that database migration plan to move to AWS. So hopefully that clarifies, where these things sit if you've perhaps looked at one or the other previously. And overall, that's pretty much what I wanted to talk to you all about. Once again, thank you for coming, and yeah, happy to take any questions. Yeah. Yep. Yep. Oh, no, wait. Oh, of course. Yeah, so all this is another capability or function of DMS on top of what's already there. In the same way we recently, not too recently, it was a couple years ago, we added data validation. That's just something on top. This Fleet Advisor is just something on top of DMS. You can very much continue to use the service for ongoing replication, and we continue to enhance it and make that better as well. Yep. So DMS is it's a logical replication product, right? So we are querying the database logs to move things from, a source to a target. It doesn't do a complete database sync as far as your full schema goes. Again, if I go back to, I think I mentioned earlier in the presentation, the DMS will just create the basic table that it needs, the table with the columns and the same data types and what have you. So if you do something that sort of fits into its sphere, if you will, so you add a new column, yeah, DMS will happily move that across and replicate that from a source to target. But if you were to go and modify a stored procedure on your source, DMS is not going to replicate that across. Yeah. And same goes with a constraint. It won't replicate that. It's really concerned about replicating the data as opposed to the schema. Yeah. So when you're starting a migration with DMS, you can do it one of three ways. You can leave whatever exists there. So the idea being you've pre-created your schema, whether you use the schema conversion tool to do it or you created it manually, DMS will just go, okay, so there's something there, I'll happily use it, no problem. You can tell DMS to drop and recreate, and it'll just drop it and build, again, that minimally viable table that it needs and populate it. Or there's a truncate option. So if you've maybe had a failed run and you wanted to clear out that table before reloading it, it'll do that as well. Yep. Select star, basically, yeah. So I'll defer that one to Mahesh, actually. Mahesh, are you aware of details there on the permissions and privileges? Well, maybe we'll catch up afterwards. Yeah. We'll catch up afterwards. Yeah, no worries there. Does anybody else have any questions? Yeah. Yeah, so yeah. So, I mean, I can't talk too publicly about the roadmap, but of course we're going to want to enhance things and make it easier for customers to decide as the best platforms to move to in AWS. Yeah. Mm-hmm. Yep. So lots of customers do use DMS as a bit of a DR tool, if you will, but you need to be aware of the limitations. So, like we were talking about earlier, the schema changes won't necessarily get replicated across. And because it's not intended to be a DR tool, there's no monitoring that says, oh, your source went down, therefore you should probably flip your applications over to look at your fallback, if you will. DMS will just, the data will be there, but it doesn't know that you should execute a failover, for example. There's queries you can do to determine where you are in the log stream, if you will. And when you initialize the new stream for DMS, you say basically start reading transactions from the log at this point. So whether it's a wall log and you're at this milestone, or this SCN number for an Oracle system, for example. Yeah, exactly. Yep. We have seen people, essentially what it comes down to is DMS does not have conflict resolution. So people have used it for two-way sync if they are unrelated sets of tables. But if you try to sync in both directions with the same set of tables, eventually you're going to have problems, because we just can't handle that if things get out of sync. Yeah, they don't. That's what I'm saying. It doesn't work. They don't do that. The only thing they do is if they have unrelated sets of tables, right? So maybe they replicate the customer table from the source to the target, and then they'll replicate the vendor table from the target back to the source. Like, that'll be fine, but not the same tables. Yeah. Yep. Yeah. One of the very, very common use case that we've actually seen a lot of growth in recent years is people using DMS. The source will be, or say, a relational database, and the target will be S3. It's very, very common for people to use that and just basically build a data lake or integrations or what have you by feeding data to S3, and you can choose a CSV format or Parquet. Yep. So we always say with DMS that it's an ETL tool with a big E and a big L but a small T. So there are some transformations you can do. We're expanding it as time permits, but it's never going to be like a full-blown, really advanced transformation tool. People have quite often integrated with other things, so they'll feed it to a data lake and then use EMR to do some funky things on top of it there or what have you. Yeah, exactly. Yeah, you're welcome. Yeah. So it's not so much scanning the network originally as it is getting the inventory from your domain controller. So it's yeah. Yeah. So basically what it is you use LDAP to get that initial list, which is pretty non-invasive. And then when you're deciding which objects you want to add to the monitored objects, only those ones will we go and do further analysis on. So that's the way you filter it down. Yeah, just to, yeah. No, DMS won't move the schema to Kafka. No. Sorry, I'm having a bit of trouble hearing you. Sorry, the masks are fun, I know. No, the DMS is very very limited in its schema capabilities. SCT does a lot more there, but again, SCT doesn't support Kafka as a target. So unfortunately, I don't have a great answer for you on that one. Sorry. All right, I think we're good. I'll catch up with you in a second regarding the SQL log access. And otherwise, thanks again, everyone, for coming. And thanks, guys, for handling all the AV stuff. Thanks.